Welcome to the Louisiana 2025 Mathematics Constructor Response Task webinar. My name is Danielle Ricks, and I am the Math Assessment Coordinator for the Louisiana Department of Education. This webinar is being recorded and will be linked into the Assessment Guidance Library later this month. As we begin this webinar, I want to remind you of Louisiana's approach to assessment. We believe that whatever assessments we make for students, that they be accessible by all students, regardless of which city they live in, which school district they are a part of, regardless of where they live or their abilities. We want to make sure our assessments are always aligned to the curriculum and the Louisiana Student Standards for Mathematics. Today, as we begin this webinar, I want to just go over the objectives and what the plan is for today. We're going to review the constructor response design and format by each task type and review the supporting assessment resources that can help you to understand these tasks and their evidence statements and how they are assessing the student. We also want to highlight the statewide patterns in student responses and student explanations in writing that are adversely affecting their constructor response scores. And we would like to provide some instructional practices and recommendations to address these adverse patterns. Now, as we move into the statewide patterns and student responses, these are some highlights as to what is preventing students from earning points and what is causing them to lose points that they would have otherwise earned. Some of this information was presented at the Teacher Leaders Summit in June of 2018, so some of this will be a review if you attended that session. One of the major 2 points when our hand scorers are grading our students' responses is that some responses are leaving out key components. So they're not giving a full response. They're only answering partial pieces of the item. What our hand scorers are seeing is that for the most part, what is preventing the students from earning points is partially responding, leaving out key components of a full response. Definitely with these multi-step problems and with the explanation and the reasoning when we want the answer and an explanation or justification. The other thing is when they're missing the connection between content and conceptual understanding, meaning there's a disconnect there. They understand one part but don't understand a second piece of it. So let's look at some examples. Partially responding and leaving out key components. This is a 3 through 5 item where the child was supposed to determine a cost based on the information presented in the table, and the only thing they did was gave the answer. They lose a point automatically for not showing the work or explaining how they got it. Anytime it says show or explain work means that the student will get credit if they do the work or they provide an explanation. It doesn't mean that they have to do both. This is a 6 through 8. What was the total mass in grams of the chemical in the container before the science removed the sample of 39.1 grams? Show your work or explain how you know. Well, the student has answered the question, part 1. They began some work or began an explanation in the form of an equation, but they haven't carried it through. I am grateful to see this equation. It shows me that this student can not only relate these concepts, but you haven't shown me your flow. So you only get credit for this one item. That is the correct answer, but your work is incomplete. It is not sufficient. It is a model, but you have not shown us how the model gives us this 149.5. Again, getting 1 point instead of 2. And this is high school. They're asked to create an equation based on the thin context here and to justify the answer. The student was able to get the equation, but there was no justification provided. Where does X come from? Because it's not referenced here. What does X plus 4 mean in the context of the problem? Why are you multiplying? Those are the types of questions that are still lingering. This equation is correct, and we obviously know the student understands, but they only get 1 point because they only get 1 point because they have not satisfied this piece. Okay, missing connections between content and conceptual understanding. This question is about the student proving that there is a relationship between multiplication and division. And it says, use multiplication to explain why this is true. And when we say this, we're referring to this particular set of values that are presented here. Now, the good thing is that this is an example of the child showing that they have the conceptual understanding completely, because the quotient, when you multiply by the divisor and then the remainder, the child is showing that they have a true conceptual understanding of the relationship between multiplication and division. By saying this is true because the quotient multiplied by the divisor plus the remainder equals a dividend. That is exactly correct, no matter which multiplication problem you have. However, the child hasn't supported it with using these values that's presented. Actually, not only do we want a statement like this is great, we want it to be shown using the numbers so that it is proven. Grade 6 through 8, same problem. Okay, the child is shown where they got the 44.85 from, and then they continue on with their process. They have a good sequence of items, but there's a disconnect here. As the child gets to this point where they say 39.3 is equal to 1/10, they're misinterpreting okay, and here is a second example, missing the connection between constant, missing. And here's another example of missing the connections between content and conceptual understanding. So the child has gone through the process to begin solving, and they knew that 5 3/4 was taken away, so they start with this plus situation, which leads to this. They've taken 44.85 and divided it by 3. I understand why they may have thought to divide by 3 because of this 3/10, but one, they shouldn't be dividing by 3. They should be dividing by 10. And 4.85 divided by 3 is not equal to 39.3. I get their interpretation that 39.3 is equal to 1/10, but this is also correct because the solution that we would get here would be equal to the 1/10. And then whatever this value was, it should be multiplied by 3, not 10. So the child has some knowledge. It's just this, so we can see that the child has some knowledge, but it's disconnected. It's not quite in sync. They know where they want to go, but the process is incorrect, and the mathematics involved is also incorrect. And then we have one at the high school level. In this figure, the child is supposed to determine whether the length of the segments is appropriate for everything else about the problem based on AB being parallel to ED. So the child comes up with a solution and says yes, because triangle ABC and triangle DEC are similar by the angle-angle postulate. Therefore, the sides must be similar. Okay. Now we have a high school example of the missing the connections between content and conceptual understanding. The child is able to deduce Now we have a high school example of missing the connections between content and conceptual understanding. The problem is asking for the student to prove whether these sides are possible based on these two triangles, knowing that AB is parallel to ED. Are these dimensions reasonable? Justify the answer. The student comes up with an answer, and their justification is the triangle ABC is similar to triangle DEC because of the angle-angle postulate. Well, it's true that the angle-angle postulate does apply here, but the angle-angle postulate actually lends to congruency, not similarity. So that's one error. Similar triangles can be congruent, but not all congruent triangles. The student has come up with an answer by saying that triangle ABC is similar to triangle DEC by the angle-angle postulate. Well, the angle-angle postulate applies here, but it's more about congruency, not similarity. There's an extra step that the child must take to prove that a congruent triangle is the student has come up with their answer by saying, yes, triangle ABC is similar to triangle DEC by the angle-angle postulate. Where the angle-angle postulate applies in this problem, they still have not proven the similarity, because in similarity, these sides should also be proportional. So this is incomplete knowledge, and they're missing the connection between content and conceptual understanding, the difference between being congruent and being similar. There is more that needs to be done. So how can we address these? How can we help students not make these mistakes? Number one, and probably the favorite item and the easiest fix, is to use the highlighting tools for CBT, which is computer-based testing, and the paper-based testing. The grades 3 and 4, you are allowed a highlighter for the paper-based test. Have the students highlight what the question is asking, so that when they're done with their response, they can go back and say, have I determined how many pictures is in each package? Did I show my work? Did I determine how many packages he bought? And did I show my work? The other thing is, when they're not broken down like this and it's one big word problem, the student can still highlight the main question involved, or they can choose to highlight the information right above the answer box. This tells them exactly what we are looking for. We want an answer to the question, which is how many more minutes does Andre spend at the library? We want the work that goes with it, show all the steps for solving the problem, and explain each step. We want to see those explanations. So if they include all three of these pieces and they have verified that they have done all three of these pieces, they have a better chance of earning those points. And again, this is a simple fix to making sure they don't leave out components and don't fully answer a question. In terms of missing the connection between content and conceptual understanding, this is coming back to the instructional side completely. Making sure that students have frequent opportunities to express their mathematical reasoning and modeling in writing, actually getting these responses down so they can see for themselves if they're answering fully. Provide students frequent opportunities to collaborate and discuss their mathematical reasoning and modeling techniques with each other. This will address the content and being able to make the connections, being able to talk themselves through the problem so they can see, even when they do write it down, where it is wrong, where it is incorrect, and provide students opportunities to examine, score, and critique peer responses. Being able to actually see an item that's done right or a response that's answered correctly, being able to see one that's partially correct, and being able to see one that's not. So when they're writing their own responses and they're creating these explanations or showing their work, they can still be thinking about, is my response complete? Would this earn full credit? Have I provided all of the pieces? It's a reinforcement to providing a full response. In terms of instruction, when you're given a constructive response item, most people want to give them in one setting. Here, constructive response, answer, turn in. Why not break it down? Why not give it to them in pieces? If there's a part A, B, or C, why not give some preliminary work, whether it be a little simple fluency drill that may address the math that's for part A, and then give just part A and grade that piece. Part B, giving some preliminary skills, a preliminary practice set that will allow them to address part B from the conceptual or application perspective. The idea is to make modifications to the task to help students understand the individual components of the task. Sometimes we need to modify the values or the number types, meaning if you're at the grade 3, 4, 5 level and you're using numbers that are in thousands, let's try with numbers in the hundreds first on that task to see maybe it's not the task itself, maybe it's just the math involved. If you're at the anything with a fraction, any time a fraction is put into a CR, it's going to be hard for kids. But when a task is presented with fractions, how about presenting it with whole numbers first and then backdooring it with the fractions so the child can see the connection between the two? The task is the same, the strategy is the same. This will allow them to focus on the conceptual or conceptual. This will allow them to focus on the contextual or conceptual aspects of the task instead of just being bogged down by the numbers or the number types. Don't be afraid to give a task over and over and over again. Change the numbers and give it to them again. Change the number and give it to them again. Change the numbers and give it to them again. Why? Because it's building fluency with the task type. If I'm specifically asking you to judge the flawed reasoning or describing where someone is correct or incorrect, I can give you multiple tasks that do that. If I'm looking at your reasoning on the number line diagram, why not give them multiple items where they have to reason about the information using a number line diagram? This again will build fluency with the task type. Okay, again, partially even our response, missing the connections. How do we address it? Let's highlight on items to make sure they're answering all parts. Let's create opportunities in the classroom to write, to collaborate and discuss, to examine, score, and critique others' responses. Let's make modifications to these tasks. It doesn't matter if you find a task from an open resource. When you look at that task, not always giving it as the whole thing, not always giving it in the form that it was originally presented. You can modify it and make it more appropriate for your students so that you can build on their understanding of the mathematics involved, build on the concepts that are needed for a specific type of scenario, and building on their ability to answer the different task types that are available to be assessed. Start with versions of tasks that are more manageable. Alter the task. Address the needs of your different learners. You can put a tag, give them a constructed response that's below level. You can put it on grade level, or even trying for your above grade level. You can alter tasks that address the needs of different students or different learners. Giving constructed response that's at the grade level below. Giving constructed response that are on grade level. For advanced students or your stronger students, giving them work that's above grade level. That is okay. Just create the opportunity for them to work collaboratively and make sure that when it is necessary, breaking down tasks that require a lot of interpretation or a lot of work. These are the ones that's extra wordy, making sure that they understand what that scenario is saying. And now we move on to what's happening when they write. Okay, the last one is what is preventing them from earning points. The patterns in writing is when they give us a response, what stops them from keeping points that they've already earned? Well, one major issue is that they have explanations that do not translate into correct mathematical processes or equations. They have incomplete mathematical explanations that lack the necessary detail to illustrate that they completely understand what's happening in the problem. And my favorite is when students over-explain. When they put so much wording or so many details that they talk themselves out of a point because they've stated something in the explanation that is not necessarily correct. Again, this is about preventing students from keeping points they have already earned. That's what these problems do. Okay, so I'm going to give you an example of what it's like when it does not translate into a correct mathematical process. Now let's look at an example where we have an explanation that does not translate into correct mathematics. So in this sample, the student is supposed to take 1218 and divide it by 4 and just get the quotient and provide the work. So the child writes this as a response. Instead of showing work, they provide an explanation. That's totally okay. I got my answer by, and it says the answer is 304, remainder 2. I got my answer by dividing 12 into 4, which is 3. That left 0 and brought down my 1, but 4 can't go into 1, so I put a 0 at the top, and I had to bring down the 8. 18 can divide into 4 times. 18 minus 16 give me 2 left over. So in this response, we know and we can tell this child knows exactly what they're doing. But this misstep of saying dividing 12 into 4, which is 3, no, dividing 12 into 4 is actually 1/3. So they need to say dividing 4 into 12. So they would earn 1 point instead of 2. We see that the student clearly understands the process, but mathematically speaking, the highlighted section is incorrect. And something like that can prevent a student from getting the point that they deserve. It's all in the wording. It's all in the writing. Okay, different student, same problem. That student chose to explain, this student chose to show the work. Okay, answer 304, remainder 2. 4 times 3 is 12. 12 minus 12 gives me 0. 018 divided by 4 equals 4. 18 minus 16, 2. This student has provided support for their work. We can see that they multiplied 4 times 3 is 12, subtracted 12 from the 12, got 0, brought down the 1, brought down the 8, and then divided that by 4. They got a 4. So then they had to do 18 minus 16, and that gave them 2. This child clearly knows exactly what they're doing, but they're only going to earn 1 point instead of 2 because of that. But they're only going to earn 1 point instead of 2 because this is considered a nonsensical math statement. I know what they intended, but mathematically 12 minus 12 does not equal 4. Okay, now we're going to move into the incomplete mathematical explanations. 3/12 lasagna, use division to rename the fraction. 3/12 equals 1/4 because I can divide by 3. Well, yes, this is the simplified version. Yes, you can divide by 3, but what are you dividing by 3? This lack of detail and proper vocabulary can lead to an incorrect interpretation of the student's process. It earns 1 point instead of 2. The child should have said, I can divide the numerator and denominator by 3, but if you take 3/12 and just divide 3/12 by 3, you're not going to get 1/4. And this is an example of responses that over-explain. So 2 girls are supposed to find the area of a rectangle. One says the area is 20, one says the area is 9. The students identify who they agree with and explain their answer. So this student goes on to tell us why she feels Vishal is correct. I know this because to do area, we have to multiply, and when you do perimeter, we add. Vishal multiplied and Maria added. I checked the work of the perimeter of the rectangle, which is 4 times 5, and it equals 20. And I added 4 plus 5, and it does equal 9, but it is the perimeter. That's how I know Vishal has the right area. In their attempt to explain every step of the way, which is totally okay and warranted, they were so caught up in the wording that they did not realize that they put perimeter here instead of area, which is 4 times 5, and it equals 20. They also said I added 4 plus 5 and it does equal 9, but that is the perimeter. That is also not true. The perimeter in this case would be 4 plus 5 plus 4 plus 5, which would be 18. So these two elements, a part of her explanation, are mathematically incorrect. So she would only earn 1 point for identifying the correct student. And then she would not earn a second point for being able to explain each piece of the pie. But she would not receive the second point for not correctly and properly explaining. But she would not receive the second point for properly explaining her justification here. So how do we address the patterns in writing? How do we get kids to stop over-explaining? Stop providing So how can we get kids to stop over-explaining and giving more concrete, detailed information? How can we get them to start providing more detail? How do we get them to not have these mathematical statements that are nonsensical? How do we get their language to be correct? So let's address that. Again, as with the last one, let's allow multiple opportunities to write. In the last address for the statewide patterns, just in responses, give them opportunities to write. This does not have to be only for CR tasks. You can do this in terms of a multiple choice item. Solve this, select your answer, explain how do you know you are correct. What reasoning can you provide? What justification can you provide? And that way they are practicing on a lower level. That way they're practicing on a lower level, piece by piece, sentence by sentence. Some of you may be familiar with math logs or math journals writing to an audience, which actually supports the English, where they identify the person they're writing to. Even within their homework, have problems that they solve in class and make the homework. I want you to go and write out the steps to solving this multi-step problem. I want you to tell us why you chose to use this method to solve a question. And this is after they've done it in class, after you know that they have the correct answer. See if they can reiterate that process. When you are grading constructive response tasks, allow students the opportunity to correct it before you count it. So if a student turns in an item and you see that the writing is not as high as it should be, or it's not as inclusive as it should be, you let them know it is incorrect and something is wrong, and then you have them correct it. And then when they turn it in the second time, you count it, or the third time. It's totally up to you as a teacher. But the idea is that you're pointing out something is wrong, and you're giving them the opportunity to fix it, because it's the learning is in the fixing. The learning is in repairing that response. This also encourages them to reread what they wrote. That is the biggest thing that can help in a situation like we are experiencing. When they write a response, once you're done, go back and reread it. Make sure that you have said everything that you wanted to say, and what you wanted to say, that's exactly what you said. Focus on being impartial when you're grading. I know we know our high students from our low students from our ones that just fall in the middle. But when their responses go to our hand scoring teams, they score what is written, not what is intended or implied or what they know the child knows. And you should always do the same. If Jenny, the perfecto, isn't perfect, you let her know. She will fix it. She will correct it. When your low kid is not right, you let them know you're not right. And you can give them pointers on how to fix it. Accommodating the learner is key here. But the idea is being impartial. Score what is written and not what is intended or applied, or what you know that they can or cannot do. And again, providing students the opportunity to read and critiquing peer responses can also be a way of reinforcing the writing, because they can look at the structure of how somebody else wrote it, or even identify errors. Why is this so powerful? Because kids like telling other kids they're wrong. And they'll do a better job of analyzing it just to prove them wrong. They want to find the incorrect. Now, this is something just as a note to you as the teacher and what goes on when these items are scored. Mathematical responses do not have to be in paragraph form. None of them do. They do not have to be in paragraph form because this is not English. They don't have to be grammatically correct, and spelling is not penalized. But more importantly, for those kids that over-explain or the kids that run out of room, the new character count has increased to 10,000 characters. So there is no way that they're running out of room. They just need to make sure the room that they are taking up, it is meaningful. Again, grammar and spelling are not going to be penalized. We don't care if they didn't end the sentence or it's a run-on, long as it's not the nonsensical mathematical run-on, long as they can translate into an appropriate mathematical equation or expression. And keep in mind, their explanations can be a mixture of words and mathematical expressions or equations. I did 3 times 5 equals 15, period. That's still a sentence. And even though the only words were I did and everything else was a mathematical character or a time symbol, that's totally okay. It's still an explanation. Now, I would like to show you just one more thing, and this is just a sample that shows that student writing should be able to accurately translate into detailed process or an athlete. Now, this is another way that we can address the patterns in writing, because students should be able to accurately translate their writing into a detailed process or accurate mathematical work using mathematical language. So I want to show you something. Now, in the past, we would give these to kids and say, hey, go locate these keywords in a problem because they're going to tell you what to do. And we're all familiar with these, and we can get one of these off the internet. However, we need to reverse the process. Instead of asking them to locate these within word problems, let's stop doing that, because they're not used as often as they used to be. This has changed a little bit, but what has not changed is a student's ability to use these words to give their own responses. For example, I found the sum of 6 and 7, and it equals 13. I combined 6 with 7, and my answer was 13. The total of 6 and 7 is 13. The student can use this for their writing, not to go find it in a question and let it be the indicator to what operation. Let it be the indicator of the operation in their own responses. The only thing that I will point out is you have per and each, which can go multiplication or division. I would also like to point out, sometimes in our responses, children say, I did 3 plus 5 and got 13. I'm sorry, I did 3 plus 5 and got 8. That's fine. Because they use the word plus, or they possibly use the plus symbol, we will accept got as a part of that response to indicate equality. However, if the student says, I had 3 and 6 and got 9, we don't know what he did with that 3 or 6, because 3 and 6 is 9, 3 and 6 is -3, 3 and 6 is +3, 3 and 6 can be 1/2. If I divide, 6 divided by 3 is 2. So when you say I have 3 and 6, how did you have it? What operation is there? So we want to make sure if they're using languages like I get or I got, it gives me, or it will be, that they've also included a clear operational sign, symbol, or word before that, so we know what was done between the values. Okay. Explanation should also include grade-specific academic vocabulary. There are words that students should be aware or familiar with. They should know their meaning. There are words that they should understand. That means they know the meaning well enough to apply it within at least a type 1 item. And when they are using it, this term, it must be properly used in written explanations, such as type 2 and type 3 items. And I'm going to give you another example. So I went through the grade 7, all of the standards, and just pull out words that could possibly be considered, and pulled out words that could possibly be considered academic vocabulary. So let's start with something like multiplication or difference. They should be aware of this. They should be able to, they should understand the meaning. They should be able to apply it in a type 1 setting, using it and understanding it for that reason, and also be able to use it in writing to write out a response. So I went through the grade 7 standards, and I pulled out any word written within the standards that could have possibly been considered academic vocabulary. And so I looked at those words, and I came up with an aware column, and understand, and a use. Again, aware says that they are familiar with the term and its meaning, or should be. They understand the term's meaning well enough to apply it within type 1 items. Or if they're using this word specifically in written explanations within type 2 or type 3 items. So when I look at this, let me just pick a random. Constant of proportionality, which is a big one in grade 7. So yes, they need to be aware of this term and understand its meaning. Yes, they need to be able to use it and apply it to a type 1 item. So understand it enough to calculate this constant of proportionality or determine it from a graph. But they should also be able to use this as language within a written response. Now let's look at a different one. Percent increase, percent decrease, and percent error, which is probably all 7th grade teachers' favorite subject to teach. But should they be familiar with these terms and aware with their meanings? Yes. Should they be able to understand them enough to use them in a type 1 problem, meaning they are going to apply it and perform these calculations? Yes. Are they necessarily going to have to use this language when they are giving their constructed response items? No, they can. But if they say the percent changes, that's the same thing as a percent increase. It changed up, a change down. Okay. So this is not necessarily going to be used in constructed response language. A child can use it, but it's not going to be required. Okay, and again, these are just sample documents that I pulled to try to help you to understand my meaning of this latter slide. Just making sure that they are translating into mathematical language. Again, reversing that thought of finding the keyword to tell you what to do. How about using the keywords so you can tell someone reading your work what you did? Or when you're using those vocabulary and you're teaching vocabulary in your classroom, when you are doing that, please think about, as a teacher, should my child or my student just be aware of this and its meaning and that's it? Should they be able to be aware and understand it, meaning they're going to apply this to a solving context? Or should they be able to use it in writing and be able to use that word or that phrase as a part of a written explanation? That's for you as a teacher to decide based on the vocabulary that you give your students. All right, now it's time to wrap up. Again, this webinar is being sectioned into 3 pieces, so it'll be 3 separate webinars, just to make it more accessible for you in the districts when you're presenting as part of a PD, or when you are reviewing it to create your own presentation. It makes it more manageable in time. So what are the next steps? As teachers, I would instruct you to go back and look at those type 2 and type 3 evidence statements and the corresponding standards within your assessment guides. Again, I have the compiled evidence statement documents that if you email me at my email here, my direct email, or my secondary email at assessment@la.gov, I can get those documents to you and a copy of this presentation as a PDF. But again, I would strongly suggest that you look at those type 2 evidence statements and pay attention to the standards that relate, so that when you are teaching and you're on that standard itself, you can consider implementing some constructive responses that assess that standard at that time. I would also strongly encourage you to analyze those achievement level descriptors and really understand what is basic and what it looks like for each standard group, and these constructive response items. Exposure. Give your students different constructive response tasks, type 2 or 3, the form of reasoning required or the required modeling. Change it up. But when you pick one, think about not giving it in its entirety, okay? Think about not giving it to the student in its entirety. Think about changing it up to making the numbers better. Think about providing them an opportunity to solve them with someone else. And as you practice, make sure that you're encouraging them to answer all the questions within a CR task, and writing responses are in process to any question type. So just so they can get that practice of writing, they can get that practice of listing out their processes. And keep in mind also, when they're doing their responses in that constructive response box, as we don't need a paragraph, we don't need necessarily a sentences either. We can have a student that listed out a step. Number 1, I did this. Number 2, I did this. And whether they do that from the written aspect in sentences or using the steps of their problem, they are allowed. We will grade whatever is within that written response. And if you want to practice in the boxes themselves, for a paper-based test, you just do it on paper. Those boxes are a little bit smaller than what's available on the computer-based testing because they fit like maybe a page. But just having students practice writing in that box. And if you're on the computer-based side, using the OTT, and even if you are a paper-based tester, you can still use the OTT to have students typing their responses in the box. You can give them a question at their desk and then have them open the OTT and just open a constructive response box and start giving a response as you walk around and read their writings and give them critiques. But again, I am Danielle Ricks, the Math Assessment Coordinator at la.gov. Again, I am Danielle Ricks, the Math Assessment Coordinator for the Department of Education. I can be reached at danielle.ricks@la.gov or at assessment@la.gov with any questions that you may have. I have also linked the resources that I discussed today. This link takes you to the Assessment Guidance Library, where we can find the assessment guides. And this is where the webinar will be posted in terms of the PDF. The practice test library, where our practice tests are located for paper-based, and access to the practice test for online is given. And this takes us to the assessment library, where these achievement level descriptors are located. As you know, EAGLE is a part of the eDirect system that you have access within your district. And the LEAP 360, also a part of the eDirect and DRC Insight system. This will be contingent upon your district having done the necessary work in the computer to make sure you have access to these when you log into eDirect. But again, if you have any questions, please feel free to email me. It's been a pleasure presenting with you today. Y'all have a good day.